Hello everyone, and welcome to this video on building linear models from data. This is going to have a few parts. This part of the building linear models from data video series is on scatter diagrams, also known in most statistics textbooks as scatter plots. So scatter diagram, scatter plot, and it's just a lot of plotting points. And we'll get into the actually building a linear model from just a collection of points on the plane in a video after this. Alright, so what I have for you in this video is just a table of ordered pairs, a table showing a relationship between two variables, and we're asked to make a scatter diagram that represents that table, those relationships. And also, looking at the scatter diagram we create, say something about the relationship between the two variables in question. All right, so let me begin. So what I have for you here, I was making these with a ruler, please ignore all these excess marks over here. So the data listed below represent the total cholesterol in milligrams per deciliter, and the age of males, I guess I should put it that the age is in years. Okay. And so we see here that this is just a sampling of males and a recording of these particular males' ages and their total cholesterol in milligrams per deciliter, of whatever blood sample they gave. Alright, so I have this sample of, let's see, looks like there's 10 males, 10 rows here. And each one of these is an ordered pair, so I'm going to be able to like plot it on a coordinate plane just like I would any other ordered pair to show a relationship between age and cholesterol for a particular male. So we see that one male was 25 years old and had a total cholesterol of 180 milligrams per deciliter. Another male was also 25 years old but had a cholesterol of 195 milligrams per deciliter, and so on. 28, 186. The next pair, 32 to 180. Next pair, 32 corresponds to 197. 38 to 239. 48 to 204. 51 to 243. 62 to 228. And 65-year-old male with total cholesterol of 269 milligrams per deciliter. Alright, so let's take a look at that table. We're going to use it to, part A, draw a scatter diagram treating age as the independent variable. Alright, so I'm going to treat the age column, as I've already written it here, as X, my input values. And total cholesterol will then be treated as the dependent variable, which is usually represented by a Y. Alright, so notice the Y up here in my table. And as I mentioned before, a scatter diagram is also known as a scatter plot. Alright, so if you're ever looking in a statistics textbook, right now I'm pulling this, we're doing this out of an intermediate algebra textbook that I'm looking at. But if you're looking at most statistics textbooks, call these drawings, these plotting of points that show the relationship between two variables, a scatter plot. Okay, so I'm going to do that. I have some graph paper here. You don't have to use graph paper. I just find it's easier to make markings equidistant and make a much more consistent and pretty picture when you're drawing on graph paper. All right, so here I have a piece of graph paper that I've already labeled, drawn with some markings. I have the horizontal axis, and remember the horizontal axis is usually reserved to represent the independent variables, and we were asked to have the independent variable be age. Right, so this is the x-axis, the age axis, and all these numbers you're seeing here, very tiny numbers, I'll point them out, are in years. And the vertical axis, right? This is the y-axis represents the dependent variable, which in this particular table is the total cholesterol in so all these numbers here, again very tiny, represent milligrams per deciliter. And I've titled it, total cholesterol of males at a certain age. All right. So it's titled, it's labeled, axes are labeled, numbers, and I have consistent markings on my axes. Notice how every square on the horizontal axis represents a distance of 5 years. So you have 5 years, 10 years, 15, 20, 25, 30, etc. And I'm also consistent on my y-axis, my vertical axis. Every single notch, every square represents a difference of 20 milligrams per deciliter. So there's 20 milligrams per deciliter, 40, 60, 80, 100, 120, 140, etc. All right. And all a scatter plot is, all a scatter diagram is the plotting of all of these points, all these ordered pairs, showing the relationships between, in this case, age and cholesterol. All right, so I've got the table up here. Let's put the table next to this. So again, remember the horizontal axis is X, the ages, vertical axis is Y, the cholesterol. And we're just plotting these ordered pairs as we would any point for any function or any relation that we were given between two variables, two sets. All right, so we have this ordered pair, 25, 180. So a person who, a male who's 25 years old, so I go 25 on the horizontal axis, has a total cholesterol of 180 milligrams per deciliter. So 25 on the horizontal, and then 180 on the vertical. We're at this location right here. That is this point. All right, so this dot represents that one person, that male, and it represents the age and total cholesterol of that one male. So I'm going to be making 10 dots here, 10 points. So bear with me. We're going to do this. I'm going to eyeball this the best I can. All right, so 25. Next person, next male, was 25 years old, and a total cholesterol of 195 milligrams per deciliter. So 25 years old, and now 195. And I've got 180, and then 200. So it's really close to the 200. So the dot again, right above here, right under 200. Make it a little smaller this time. Okay, so there's one dot for the first male, another dot for the second male, and I'll try to make the dots around that size from here on out. All right, the next male, 28 years old, 186 total cholesterol. All right, so 28. That's between 25 and 30 here. All right, and they'll be closer to 30. And then, so I'm at 28 years old, and then 186, which is again between 180 and 200, but closer to 180. So a little closer to 30, 28 years old, and then 186, a little closer to 180. There's another dot right there. Okay, so 3 dots for 3 people, 3 points. Then 32, 180. So a little above 30, all right, 32 years old, and a cholesterol of 180. Maybe about there. All right, 4 points for 4 people. 32, 197. Okay, 32, 197. Right, so a little closer to 200, but the same in line with this other point. All right, this point, the person was 32 years old, so it's right above that, same age, but a little higher cholesterol. So let's say here, really close to 200, maybe even almost on that line. Right. So now I've got 5 points for 5 people. Then 38 years old, 239 blood cholesterol, total cholesterol. So 38, closer to 40, and then 239, closer to 240. So 38, and really up near 38, up, near 240, maybe around there. And there's the 38, 240. 239, my apologies, 38, 239, just below 240. 48 years old, and then 204 for the cholesterol. So 48, closer to 50, and then 204, all right, so a little bit above 200. So 48, and then 204, so maybe around here. All right, so we have 7 points up for 7 people. 51, 243, 51 years old, so a little above 50. 243, cholesterol a little bit above 240. So 51, 243, so maybe about here. And 62, 228, right, so above 60, 62. And 228 would be like about halfway between 220 and 240. Right? So 62 and then 228, maybe around there. And just eyeballing these things. Doing the best I can with the with the units I've set up. If you want to, do finer units than 5 and finer units than 20, be my guest. You can make it however you want. Just make sure you're consistent. And then finally, the 10th point for the 10th male, 65 years old, 269, so basically 270 for the cholesterol. So 65 and then 260, 260, 280, 270 is about halfway between. So 269, about halfway between 260 and 280 there. So about here. Okay. And this is what's called, again, that first one kind of bled a bit. I'd like them all to be the same size, but it's okay. I can see 10 distinct points here. So there's the scatter diagram, the scatter plot for this set of points, this set of ordered pairs. And what we're going to be doing later is trying to figure out, in a later video, is trying to determine a line that kind of fits the data pretty well. Obviously, these 10 points don't all fall on a straight line, right? This is clearly not going to be a straight line if I tried to connect them all. But we're going to try to draw a line in here that fits them, that kind of goes along with the pattern. So you see I'm starting low down here, and then it seems to me, just based on the way the dots are going, the younger you are, the lower the cholesterol, and then the higher the age gets, it seems to tend upward. So it looks like a line, if you use my ruler here, going through maybe about here, or here, through those points. A line like that would kind of fit the pattern. Right? So that's what we're going to be doing later, in a later video, as I said. We're going to try to figure out a nice line that'll show us what's the pattern looking like. Right? It's not necessarily going to be, again, these do not form a straight line, but you can tell that a line, it has a nice linear, there's kind of a linear relationship between age and cholesterol. It looks like as age increases, this total cholesterol seems to be trending upward and increasing as well. Okay, and so that's why I'll say for part B. Right? Part A was draw the scatter diagram, which I have done there, and part B is now, okay, look at this scatter diagram and describe the relation or the relationship between age and total cholesterol. And that's exactly what I'm going to write exactly what I said a second ago. All right. It looks as though an increase in age tends to result in an increase in total cholesterol. Right, because again, like I said, it starts off kind of low over here for the younger males, and then as the males get older, the points seem to tend to get higher. Right. So that's all I mean by this. Now we'll talk about what kind of relationships is there between two variables in the next video. But I'll do a little kind of a preview of this. So relationships between variables. And we're going to be looking at scatter plots to determine this. So like here's a possible, if I had a scatter plot or a scatter diagram that looked like this, where all the point, as kind of like this one, where all the points as you move toward the right seem to be tending upward, then we would say, look, it looks like it's doing this, going upward. I could kind of, again, they're not on the same line, but I can draw a line to kind of show you where the pattern's trending. So this kind of relationship they would call I would say it has a positive linear relationship, right? A positive linear relationship between x and y. Because if I draw a line to show the trend, to show the trending pattern of the points, that is a line with a positive slope. Remember the lowercase m for slope. Slope is positive for that line. That's one possibility, which I'm seeing here. Right? I'm kind of seeing that in my scatter diagram here. The points are, tending to trending upward as I move to the right. Well, you could also have the points trending downward as you move to the right. Here's another possible if I draw a scatter diagram and the points seem to, as I move to the right, be trending downward, I can draw a line to show the trend, and that is a line with a negative slope, right? Remember the lowercase m again represents slope, less than 0. If you're seeing a scatter diagram like this, then the points are trending downward. That you would say that there's a negative linear relationship between the independent and dependent variables. But it might not be linear, right? The relationship might not be linear. Okay, you could have a scatter diagram. I'm just doing all sorts of possibilities here, where maybe the points don't follow a linear pattern, but if I draw a scatter, maybe they follow like a parabola or something, right? If I had a scatter diagram like that, it looks like the trend is going this way, right? It's trending like this, which is a non-linear. You could say that it's not a line, non-linear relationship. There's still a relationship, right? You can still see there's clearly a pattern. The points seem to be following along this like parabola shape here. So there's clearly a pattern, or maybe even a circular shape or something, right? There's some shape other than a linear one. There's clearly a pattern, but it's non-linear. And then one of the last possibilities that you'll come across in this, either an intermediate algebra text or a statistics text, is if you have a scatter diagram where the points are just all over the place. What kind of a pattern is that? There's no pattern here. It's not going upward to the right, not going downward as I go to the right. There's no circular pattern, no parabola, the points don't seem to be, this is just a big jumbled mess of points. So basically you would say there's like no relationship between the variables in that case, or a very weak, I guess not necessarily no, but a very weak relationship between the variables in that case. If the scatter plot shows points that are just all over the place in a big jumbled mess and there's no clear pattern. Right? The other ones kind of have a discernible pattern to them. So you can say there's maybe some sort of stronger relationship between the variables. Okay. All right. So again, we're going to come back to this in a future video, and I'm going to make fit a line in here, throw a line in here to kind of show us where the pattern's trending. But again, that's just a video or two away. Alright, so I like to say at the end of these videos, please try your best to learn the material on your own before you go looking for help. I find that it tends to stick better with people. People tend to remember things longer when they've taken the time and the effort to learn it on their own. So read the material, read the author's examples, perhaps even work on some of the author's examples before you see how the author did it, and then compare your notes, your work to the author's, and maybe you can learn from some mistakes there. Work on exercises, work on practice problems, check solutions when they're available so you can check yourself, see how you're doing. Just don't give up after the first attempt though. If after several approaches at a problem you're still not getting it, then I would recommend going back and reading the material again, more slowly and deliberately, taking notes, maybe even a third time, because maybe that second or third read through, maybe you'll see something, or something will make sense that you didn't the first time, or that didn't make sense the first time through. It'll make working on the problems that much easier. But if after that, if after several read-throughs of the material and several attempts at problems, you're still not getting it and it's still not working out for you, then it is not a sign of weakness whatsoever to go out looking for help. That is what other people are there for. Ask a teacher, a tutor, a friend, someone in the class who you know knows the material well and is willing to help. Look for supplemental materials online. There's plenty out there. Look for videos on the subject, such as this one, or and I assure you there are ones out there that are plenty better than mine, and you can find them pretty easily. But just keep at it. Stay persistent. Keep practicing. Don't give up. And I know this is easier said than done, but try to have a positive attitude about the subject. It's amazing the difference a change in attitude can make. If you think you hate something, you're probably going to continue to hate it. So go in with an open mind, thinking, I'm going to pull something from this, I'm going to learn something, I'm going to enjoy learning it, I'm going to take something away from this, and have fun maybe. And it's amazing the difference that a positive attitude can make, just a little tweak in your attitude. So stay persistent, keep practicing, stay positive, and I just know you'll eventually get it. Thank you for watching.